Hello everyone, welcome to engineering study and today I am going to cover compaction. Okay, so in my previous lectures I have already covered the index property, soil classification, effective stress, permeability. Okay, so first go through all the lectures and then come to this that is called as compaction. Okay, so first check the note here. I have given the note and I will elaborate the note in my board work. Okay, so the first thing is check the note, and the first thing is compaction of soil is a process of increasing the unit weight of soil by decreasing the volume of air and volume of soil. Okay, the first thing, as you all know that soil has three parts: solid, water and air. So when we, as you all know that only the constant term is here solid and these two terms are variable. So when we apply some load here and after applying load, let us assume the soil has come to at this place from here to here. So there should be some amount of air should remove from the soil. That's why the volume has decreased. Okay, so the removal of air by applying load is called as compaction. And here another variable term, that is water. When water will start removing for applying load, the process is called as consolidation. This chapter I will cover in my upcoming lecture, in my next lecture, and today I will cover compaction. Okay, so the compaction means removal of air by applying load. Okay, so the next line is, it is the process in which solid particles are artificially arranged, are packed together into a closer state of contact by mechanical means and in order to reduce void ratio, porosity, compressibility, etc. and to increase the degree of denseness, shear strength, stability and bearing capacity. Okay, so the thing is here, when we apply some load on the soil, as soil has solids and voids, when we apply some load here, the solid particle will slide over each other and come closer to each other in comparison to the previous state. Okay, so when it will come closer to each other, the void will be filled by the solid particle. Okay, and the air will start removing from here. Okay, as the solid particles come closer to each other, that's why the degree of denseness will increase. Okay, in comparison with the previous case, when we apply some load on the soil, the solid particle will come closer to each other and it will remove the air from the void. That's why the degree of denseness will increase. As the degree of denseness is increasing, the stability, shear strength, everything will increase after compaction. Okay, so and as the particles are come closer to each other, voids are reducing. Okay, so the void ratio, porosity, everything will reduce and degree of denseness, stability, these type of things will increase. Okay, and the next thing is compaction is the instantaneous mechanical process in which soil mass is always unsaturated. Okay, compaction is a technique you are continuing applying some load up to the removal of 100% air. Okay, when the all air has removed and the water start removing, that technique is called as consolidation. Okay, so there must be some amount of air to continue the process compaction. Okay, and compaction of soil achieved by use of vibrator, roller and rammer. Okay, the compaction of soil is represented by terms of its dry unit weight, gamma dry. I am coming to this point, gamma dry. I am coming to this point later. Just write the note here. Okay. So compaction is actually done by vibrator, rammer or hammer. You hammer the soil and you have to apply some load by any technique or vibrator, by rammer, by hammer. That's after the applying load, the solid will come closer to each other and the air should remove, and that technique is called as compaction. Okay. Now check the diagram here. Two diagram is given. In the first thing, the solid water and air, and after applying some load, the volume has decreased, and the volume is V2. So in the first case, volume is V1, and the second case, volume is V2, and V1 greater than V2. Okay. As you all know that gamma bulk equals to W by V1 for the first case, and gamma bulk 2 equals to W by V2 in the second case. Okay. So as V1 greater than V2, so gamma bulk will be less than gamma bulk 1 will be less than gamma bulk 2. As it is greater than, it will be lesser. Okay. And we all know that gamma bulk equals to gamma dry by 1 plus W. That means gamma bulk is directly proportional to gamma dry. So here you can write it gamma dry less than gamma dry 1, gamma dry 2. So it is the proof that after you apply some load on the soil, when the air has removed, its dry density will increase. Okay. So that's why the compaction is generally denoted by its dry unit weight. Okay. Okay. Now complete the table here. This is the standardization value of compaction test which will be done in our laboratory. Okay. So first is standard Proctor test, IS light compaction test, modified Proctor test, and IS heavy compaction test. And here volume of mold, number of blows of each compaction, number of layer, weight of hammer, free fall length and energy. Okay. So here the mold size has given, and each layer the number of blows should be 25, and we have to fill the mold in 3 steps. In each step we have to give we have to hammer the soil 25 times. Okay, so complete the table here. Okay, there is nothing to describe. And now the compaction curve. Okay, and how the curve has generated. The first, we have to take an empty container, that is W1, then a container with moist soil, that is W2, and we have simplified the moist soil into 3 parts as solid, water and air. Okay, and this container has a specified volume that I have discussed in my previous page. Okay, that for 945 ml for standard Proctor test, and for IS light compaction test, that is 1000 ml. The container has volume of this amount. Okay, so the first case, as you already know the volume, so gamma bulk will be W by V. Okay, V has given, so we are getting the value of gamma bulk in the for the starting of this test. Okay, so now, and from here after oven drying test, we can calculate the water content, and then we can get the gamma dry value. Gamma bulk by 1 plus W. Okay. And now, after performing the compaction test in the soil, a sample is further collected from the mold and tested for its water content, and then oven dried, which is used to find gamma dry. that indicate the compaction is achieved in the soil at particular water content. As you all know that how we can determine the water content, after collecting the sample, we have to take the sample in a container for its, and we have to put the soil in the oven for its water content value. Okay. Then from the water content value we can convert the bulk unit weight into its dry density or dry unit weight, gamma dry. Okay. Here, as you already know that compaction generated denoted by dry unit weight, so this value is important. We have to get the value of dry unit weight. Okay. And then now this test is repeated at different water content of the soil, and dry unit weight is noted for the same compactive effort. Okay. When you collect the sample and get its water content, okay, in the next day you increase its water content and then again give the compaction by the hammer. Okay, same compactive effort, that means the 3 layer 25 number of blows in each layer. Okay, and then we have to find the gamma dry value. Okay, in the first case gamma dry 1, in the second case gamma dry 2. Again the test will be repeated like this, and then we will get a curve. In the x-axis that is water content, in the y-axis that is gamma dry. And now we will get a curve like this. Okay. This is the initial stage, gamma dry 1, and when you apply some load, apply some compaction, and then you mixed up some amount of water, and then again you compact the soil, the value of gamma dry will increase in comparison with the previous value. And why this happens? Because as we already know that this solid particle will generate when we apply some load, and this solid particle will try to slide over each other, and they generate the friction. That means they will get some amount of resistance. And when we increase the water content in the second case, as the water surrounds the solid particle like this, okay, the friction will slowly decrease in comparison to the previous case, and then the solid particle will come more closer with each other. Okay, that's why the more amount of air can reduce by compactive effort. Okay, as the volume will decrease in comparison with the previous case, as the volume is decreasing in comparison with the previous case, okay, that's why the unit weight is increasing. That's why the curve is like this. Okay, again we apply mixed up some amount of water, and the curve will be like this. Again we mixed up, but at a point will come when we will get the maximum gamma dry value, and then the dry density will start decreasing. And why this happens? Because when the all solids surrounded by the water molecule, that means in this case, and then you apply then you increase the water content, and the water will not decrease the friction, it will increase its volume. It will take the void space and it increase its volume. As the volume is increased, gamma dry value will start decreasing. Okay, so that's why the curve is like this. And I am coming to this point in detail after some times in this lecture. Okay, so just know the concept how the curve is generated. Okay, how the curve is generating here. Okay, and now a line has drawn like this. It is actually the theoretical gamma dry value, and this is practical that will be done in the laboratory. You will get a curve like this, and this is a theoretical value of gamma dry. Here the complete removal of air has taken place. That is practically impossible to remove all the air from the soil. So that's why we will get a curve like this in the laboratory. But if we can remove all amount of air from the soil, we will get a curve like this, and this is actually a theoretical curve, theoretical gamma dry value. And this line we can also call it as a 0% air void line or 100% saturation line. 0% air void means no air present, and 100% saturation line means the void is filled with only water, no air. Okay. So now check this diagram here. Three stages are given. In the first case, solid water and air. Then after compaction, some amount of air has removed, and after that, the compaction has again performed, and then all air has removed. That means at this stage, soil is 100% saturation. And after this, when we apply load, water will start remove, and then that technique is called consolidation. Okay, so this is the stages of compaction. And now some points are important here. Write all of these points very carefully. Okay, important point to be noted in the given soil and given constant compacting effort. Okay, first point, practically possible gamma dry at any water content can be found by compaction curve. We can practically found any value of gamma dry at any water content by the curve which we have already covered by this curve. At what percentage of water content the value of gamma dry can be calculated from this graph. Okay. Next, at any water content, maximum theoretical gamma dry with the help of zero air void line or S equals to 1 line, degree of saturation 1. And this is the theoretical curve. At any water content, what will be the value of theoretical maximum gamma dry, that can also be calculated from this graph. Okay. And third point, maximum practically possible gamma dry will be at OMC and found by compaction curve. At the OMC, optimum moisture content, we can get the maximum value of gamma dry. Okay. And fourth point, gamma dry theoretical will be at OMC at can be found by zero air void line, and this gamma dry theoretical maximum will be highest value for that given compacting effort. Okay, that means for this curve, we at OMC we can get the maximum gamma dry value, and that will be theoretical, not practical. Practically possible, because practically it is impossible to remove all the air from the soil. That's why in practically we are getting this type of curve, but in theoretical, where we can assume that all air is removed, at that case we can get this type of curve. So at the OMC we can get the maximum theoretical gamma dry value. Okay. And fifth point, for a given moisture content, gamma dry max is obtained when compaction is such that all air is removed from the soil. Okay. A line showing water content and gamma dry of the compacted soil at constant percentage of air void is termed as air void line. Okay. So note all of these points very carefully. Okay. And study all of these notes. Okay. And now the two equation is important. First case, equation of air void line and saturated line. And as you all know that gamma dry equals to G gamma W by 1 plus E. and we all know this formula, Es equals to Wg and then E equals to Wg by S, and put this value of E here. Gamma dry equals to G gamma W by 1 plus Wg by S. That means this is the equation of saturation line. Okay, that means that what percent saturation and what percent water content, the what will be the value of gamma dry. Okay, when degree of saturation and water content has given, then we can easily found from this equation the value of gamma dry. Okay, and the next equation is equation of air void line. Okay, as you all know that air void line is equal to VA by V, volume of air by total volume. Now 1 minus eta A equals to 1 minus VA by V, that means V minus VA by V. That means when from the total volume, if we remove the volume of the air, then what will be remaining? The volume of the solid and volume of water. Then the value of this volume of solid plus volume of water by total volume. Okay, and now we have to get this value, two value, and then we can get the equation of air void line. And how we can get the value of volume of solid? As you all know that true specific gravity is equal to gamma S by gamma W, and gamma S means weight of solid by volume of solid by gamma W. Okay, and now volume of solid will be Ws by G gamma W. And what will be the volume of water? Gamma W is equal to WW by VW. Then VW equals to WW by gamma W. Then putting all of these two values here. Okay. Then what we are getting, 1 minus eta C equals to Ws by G gamma W into 1 by V plus WW by gamma W into 1 by V. Then from here we are getting that Ws by V equals to gamma D by G gamma W. From here we are getting that Ws by V equals to gamma dry unit weight of solid by total volume, dry unit weight by G into gamma W, and from here WW by gamma W into 1 by V, and we all know that water content equals to weight of water by weight of solid. Then water content will be weight of solid into water content percentage by gamma W into V, and weight of solid by volume means gamma D. So gamma D by G into gamma W plus gamma D into water content percentage by gamma W equals to 1 minus eta C. And from here if we convert generalize this form, we will getting the equation like gamma dry equals to 1 minus eta C into G gamma W by 1 plus Wg. So this is the equation of air void line. Here air void is included, and from the equation of saturation line we all know that already gamma dry is equal to G gamma W by 1 plus Wg by S. Here degree of saturation has been included. So these two equation is important. Okay. And now write down the note here and draw this graph. You can easily understand the graph now that two things has given. One is practically gamma dry value, and one is theoretical gamma dry value. Theoretical maximum and gamma dry theoretical, gamma dry practical maximum, and gamma dry practical at, that means at here this is the value of practical maximum value, and here this is the value of theoretical maximum gamma dry value, and this water content, this is the value of practical and this is the value of theoretical gamma dry value. Okay, complete this note. And in cohesive soil like clay and up to some extent in soil, max gamma dry can be achieved at 85% or 95% degree of saturation. Because in such soil, clay and silt, and also in gravel, it is not possible to remove 100% air. Okay. In case of pure sand, behavior which is different from the soils like clay, silt, max gamma ray can be found at 100% degree of saturation. That means in case of sand we can remove all amount of air, but in case of clay and silt, as the voids are very small, we can't remove the whole amount of air. That's why we can assume that at 85% to 95% degree of saturation, the whole we can get the maximum gamma dry value. Okay. Now line of optimus. Check the second note, line of optimus. Okay. Line of optimus means when we, from the IS modified Proctor test, we already know that we are giving 25 number of blows in each layer. We are compacting the soil in 3 layers, and each layer we are giving 25 number of blows. If we increase the number of blows, like in case of 25 we are increasing to 35, then the soil will compacted more, and then as the soil will compacted more, the gamma dry value will be increased in comparison to the previous case. Like if we are giving 25 number of blows, we are getting this type of curve, and now we have increased the number of blows to 35, 25 to 35. Then as the gamma dry value will increase, then we will get this type of curve. Gamma dry value here for 25 number of blow, and gamma dry value is here from 35 number of blows. If we increase it to 40, then we will get this type of curve, and if we add all the peaks, then this line is called as line of optimus. Okay. Now complete the note. With increase the compacting effort on given soil, maximum dry unit weight increase and corresponding OMC decrease. It means a particular soil and for a given water content, if compacting effort is increased, dry unit weight will increase. Okay. Now complete the note, the line of optimus. Draw this full diagram. Okay, from the note. Okay. Now again the note is here, and that is line of optimus is almost parallel to ZAVD, that means zero air void line. Okay. Generally line of optimus corresponding to 85% to 95% saturation line, and it corresponded to almost 5% air void line. Okay. Complete the note. And now water content. Okay. As we have already discussed some amount when we have already discussed the curve, why the curve is behaving like this, and at that and there I have told you that I will come after some time. We will discuss in detail why the nature of the soil is changing like this. Okay. And this is the point. This is the reason is water content. Now complete the note and you will understand why the soil is behaving like this. Okay. Now just first complete the note. Okay. At lower water content, soil is relatively steep, hence offers higher resistance against compaction and does not pack in denser state of compact, resulting in lower dry unit weight. Okay. With increase more and more number of layer of water is formed surrounding the soil solid, which induces lubrication effect, under which soil solid can be worked. Therefore, the soil solid become workable and they come into closer, denser state of contact, resulting in increase of dry unit weight. Okay. This increase in denseness of soil takes place up to a particular water content termed as OMC, at which lubrication effect is maximum. Beyond this point, if water content is increased, there is no change in lubrication effect and becomes very difficult to force out the air from the void. After OMC, volume of air void almost become constant. When water is added up to OMC, it increases the volume of the soil, but there is no effect in the volume of the air void, resulting in decrease in gamma dry. Okay. Now I think you have this concept is clear, because as we have discussed earlier that when we start adding water, the water will surround the soil solid, and when we apply load, it will help the solids to come closer to each other, and the frictional resistance will be lesser between them. But at time will came after OMC, optimum moisture content, when it will be practically impossible to remove the air void. But if we continue adding some amount of water, the water will simply increase the volume of the soil and it will consequently decrease the gamma dry, as gamma gamma equals to W by V. If volume increase, the value of gamma will decrease. Okay. So from here, the water will simply increase the volume. It will not increase the lubrication effect, as at OMC there the lubrication effect is maximum. Okay. And now complete this note. Effect of compaction on engineering properties of soil. First is structure of soil. Effect of compaction on structure is found to be more prominent in fine grained soil in comparison to coarse grained soil. At the same compacting effort, structure on dry side of optimum is found to be flocculent and wet side of optimum is found to be dispersed. In fine soil, when water content is low, then the attractive forces between the tiny particles is prominent or predominant, hence structure is flocculent. With increase in the water content, repulsive force becomes prominent, structure of the soil will be dispersed. Now look into this. In the water content, due to the increase of the water content, we know that the lubrication effect, due to the lubrication effect, the solids will easily slide over one another. Okay, we can compact the soil very easily. Okay, but due to the absence of the water content, that means from the first cases, from this point, this point, this point, here the lubrication effect is minimum. Here, if we apply some load, the solids will be stuck with one another and will form like this structure. They will stuck due to the frictional resistance, and they will form the structure like this. This structure is called flocculent structure. Okay, due to the lesser amount of water or dry side. Check here, there are two terms as written: dry side of optima and wet side of optima. Dry side of optima means the lesser water content, and wet side of optima means higher amount of water content. From the OMC, this side is dry side of optima, and this side is wet side of optima. Here water content is lesser in comparison to this side. Okay, and in this side the soil solid will form a structure like this because they will start with one another due to the friction between them. But when we increase the water content, when we start increasing the water content, the water molecules will surround the soil solid like this, and then they will start sliding over, they will start sliding on each other, and due to the apply of the load. Okay, and this case, this scenario is called wet side of optima because here this form will here the form will break, the flocculent structure will break, and the solids will be like this. Okay, and this structure is called dispersed structure. Okay, and so this scenario is called wet side of optima. Okay, when the flocculent structure will form, that is called dry side of optima. When the dispersed structure, that means the solid molecules has been dispersed from one another, that situation is called wet side of optima. Due to the increase of the water content, there the resistance between the particle will decrease and they will disperse like this. Okay, and now complete the note. Dry side of optimum flocculent, wet side of optimum dispersed. Wet, WET, wet. With increase in the water content at some compacting effort, orientation of the particle in the soil structure improves, and it means volume of voids decrease. Okay, with increase in the compacting effort at the same water content, again orientation of the particle improve and volume of the void will decrease. Okay, and now complete the curve, like draw this curve and divide the section dry side of optima and wet side of optima. Flocculent structure, dispersed structure. Okay, here we can see flocculent structure, and in this side we will see dispersed structure. And now check 2 note. With increase in the water content, the volume will decrease, as due to the increase in the water content, this flocculent shape of the solid molecule will break and they will be dispersed, and in that case the volume will decrease, as we know that the soil will compacted more densely in comparison to the flocculent structure. And again, if we increase the compacting effort, the volume will also decrease. Okay, so these 2 points is important. So complete the note, and this is the end of compaction chapter, and the next I will start consolidation. Okay.